Uh, we are live. So, hi everyone. Welcome to Naukri Learning's live session for today. And in today's webinar, we'll be talking about how natural language processing helps companies and businesses solve real life problems in the industry. NLP is an exciting domain, and we know that it impacts people, the way people do business that involves, intensive human language understanding, and this field is constantly evolving. And we can find the uses of NLP in our daily activities, which we probably often take for granted, like, for example, spell check, autocorrect, or where language is like intensively used. So, in today's talk, we will be focusing on prominent applications and processes for which companies use NLP and state-of-the-art NLP techniques and challenges that companies face in real-time deployment of NLP applications. So, to deliver the talk, it's a great pleasure for me to welcome Niharika Sachdeva, our speaker for today. And she's currently the Vice President of the Data Science team at InfoEdge India Limited. Also, do remember that we'll be taking up your questions later, so don't forget to share them with us in the live chat box so that we are also able to solve your query. And without further delay, over to you, Niharika. You can start.
Thanks, Niharika. Welcome, everyone. Thanks for joining us today evening. So as Niharika mentioned, this talk today is about natural language processing and why is it so important for industry use cases. So I'll start with a quick intro about myself. I'm, as Niharika already mentioned, I'm VP Data Science. Prior to working at Naukri.com, I have worked with Philips Research. I'm also part of ACM India PhD Clinic. So if some of you are looking for PhD level guidance or are looking for if you should join your PhD or not, so we offer, it's a voluntary program and we offer help there. I have done my PhD from IIIT Delhi, where my PhD was funded by TCS. And some of my areas of interest is machine learning, collaboration, communication, human-computer interaction, and usable security. So that's a quick intro about what I like to work on and what's been my journey so far. As we start, let me try to set the expectations for this talk today. So this talk will introduce you to a variety of industry-specific use cases where NLP is used. By the end of the talk, you will know what are all techniques that are used in these different use cases. And in each part, I'll try to cover the challenges that come when you are deploying NLP product or when you are deploying an NLP solution on a large scale. In this talk, given the time, I may not be able to cover the depth of NLP topic. So if that's the requirement, I would say that you should probably look at some of our e-learning courses that are available at Naukri. And if there are any questions, I'm happy to help there. So I hope the expectations are clear. These are some things that we'll cover today. What is NLP? Why is it of so much of interest? Different NLP techniques, industrial use cases, and then getting ready for NLP position in industry. What all it takes to really get to work. So if you search NLP on web, you will have multiple definitions that come up. Let's look at some of these and try to find out what's common among them. And that's what broadly would capture a sense of NLP domain. So the first one is it's in the application of computational techniques to the analysis and synthesis of natural language and speech. So what is natural language? The way we communicate, the language that humans use. It could be English, Hindi, French, any language that's referred to as natural language in this context. So let's look at another one. Natural language processing is a subfield of linguistics, computer science, and artificial intelligence, which is concerned with interaction between computers and human language. Again, if you will see, there was computational techniques in the first one. Now it is saying it is computers and human language, so that it's broadly the art of how computers should be able to understand human language. Let's look at this one last, another definition. NLP refers to branch of computer science, and more specifically, the branch of artificial intelligence concerned with computers' ability to understand text and spoken words. So if you kind of combine all these definitions, this is the circle or the diagram that you'll come up with. It's an intersection between computer science, artificial intelligence, and human language broadly. So if we look at this part of our domain, this is where we are going to concentrate on, or this is where most of the NLP work lands into. So why it is of so much of interest? Why am I even talking about NLP in this talk today? So this is one of the stats. I'm sure all of us are there on social media, whether it's Tyndall, Google, Reddit, LinkedIn, Snapchat. And most of these platforms, we are chatting, we are talking to each other, we are creating content in terms of blogs. So this data is huge. The world never sleeps, and so does the data also never sleeps. It's being continuously generated. So that's the amount of data. And if you look at it, most of this data is unstructured. So there are some stats that more than 50% of enterprise content today is unstructured. Whereas if you look at earlier, it used to be unstructured like 20 years back, 30 years back, it used to be unstructured, but the market cap was much smaller. But today it's everywhere. And again, it's like if we want computers to help us in our daily life, it is very important for them to understand our language and communicate to us in the same format. And for humans, this task may be very simple. For you and me, talking to each other is very simple. We understand each other. But for computers to understand and interpret human language, it's not that easy. So we want computers to help us, but the task is not easy. That's one reason where NLP picked up, and that's how it evolved. How do we make this task more simple, and how do we make it more usable as we evolve? So these are some of the NLP techniques I'll try to cover today. First, which everybody needs to know, is the basics text classification. This is like the most basic algorithm, most heavily used across industry. They're part of sentiment analysis, then information extraction, text normalization, linguistic analysis, and knowledge graphs. By the time I complete this circle, I want to leave you with knowledge graphs. And it's an amalgamation of graphs plus NLP. That would probably, I think, create interest in you to delve deeper into NLP domain. So we'll cover each of these. Do not worry about these technical terms here. We'll cover each of these in the talk, and I'm sure these will be more clear as we move ahead. So let's first start with what is text classification. So the task here is very simple. It is assigning category to the document of interest. Now, document can be anything. For example, it's an email. and Google wants to decide whether it should go to your inbox or it should go in the spam box. So they need a simple classifier which looks at the text of the email and decides where it should go. Similarly, gender classification, another example. There's documents, there are names of people given. It's a very basic, one of the most basic programs that if you do text classification, you'll get to do is gender classification. There are Indian names, doing gender classification of Indian names, doing gender classification of foreign names. That's one. Sentiment analysis can also be looked at as a specific use case of text classification where we are saying, given this particular tweet or given this particular message, is it positive sentiment? Is it negative sentiment? Or is it neutral? Three very basic classes. People have come up with more extensive sentiment analysis, which could be aspect based. For example, you are writing a review of a restaurant and you say the food here was good, but the ambience were not that great. So then you are looking at two different aspects in the same sentence and trying to classify it as one part is positive, the other part is negative. So that is called as aspect-based sentiment analysis. Another very common example is movie genre. You would, if you go to, I think, Netflix, or if you go to booking sites, then you'll see that you can select, like, is the movie belong to horror class or is it romantic? You can see movies in all different categories. So that's again a classification task. So the classification, if you see, if there are multiple classes, then it is called as multi-class classification, whereas spam, ham, gender, where it is only two classes, it is called as simple binary classifiers or binary classification. These have been the classical problems in text classification. Today, when we are so tech savvy and when we are so active on social media, there are certain use cases again that you can look at it. So let's say somebody telling you on Facebook that this is fake content. You should not trust this post. There are applications like that. Or on Twitter saying whether you should trust that piece of information or not. That's credible information on Twitter. So these are also all classification tasks. If you go to any question answering website, then they may block your question. That kind of exercise is also performed using classification tasks, or saying that your category of question, that this question belongs to, let's say, computer programming, or this question belongs to political science. If that website is doing that, that is again a kind of a classification task. So this is the most basic. I'm sure all of you would have seen it somewhere or the other. These are primarily used, heavily used in the industry. So this is for people who are into research. If you go to any of these Elsevier's, or if you go to any other like ACM, you would see that there are different categories. A particular article could belong to health, it could belong to life sciences, any of these domains. And this task of given a research paper and then saying to which category it belongs to is again a very interesting question that's dealt in text classification. Now, let's try to formulate this problem a little mathematically. So what is our input? Our input is a document. For example, let's say a movie name or some data associated to a movie. And then the second one is we want to classify it, whether it's a horror movie, romantic movie, thriller movie. These are all labels or categories or classes, which we can say that there are, let's say, J classes, then your set will contain L1 to LJ classes. And what is the task? The task is output is to predict that whether M belongs to horror movie or not, romantic movie or not, thriller movie or not. So then your final output should be one class. So that's how a very simplistic mathematical view of classification, binary. This is multi-class classification problem. So now this is how NLP and machine learning are tightly knit also. So I told you that's the problem. You know the input, you know the output. Now, most likely, you would use one of these algorithms. You would use naive-Bayes, logistic regression. You can use any of these algorithms to perform the further classification or supervised classification task. Since we know why it is supervised, because we know our training data is such that for some movies we know that these kind of movies belong to this type of category. And now as things have evolved, there are deep learning techniques also that can be used for text classification. I'll walk you through one example of what text classification really looks like. So this is one of the work that I did for police departments in India. So a lot of us maybe communicating with police departments on Twitter or on Facebook. So what we wanted to do here in this particular slide or in this particular work was to say whether that particular message will get a response from police or not. A message that solicits a response in form of an action or information from police department, then we call it a serviceable request. So the task is to say whether a message is serviceable or it's not serviceable. Let's look quickly at some examples. For example, there is a message saying there's at so and so time, this vehicle number at this particular location was crossing line by way too much, obstructing the vehicles which were coming from the entrance. Later he jumped the signal also. So this is one piece of information. Most likely this is the forward category. What police would do is forward it to their department to say that whether an image could be attached with this message, and they would say that whether a challan or whether some fine needs to be sent for this message or not. There could be some information like a humble salute for a fellow Chennite from commendable job, for doing a commendable job in rain. So there was this person, this tweet, this message, if I remember it correctly. So this was a traffic police officer who was standing in rain, and this citizen kind of appreciated his work. So this is more like, for this particular message, you will get a thank you kind of a reply from police department. There could be certain simple queries like, can you explain to me rules and regulation for transferring vehicle from Chennai to Bangalore? So this can be instantly answered. So that's the give solution category. And then there could be certain category of questions where police might need more information to support, like cops driving wrong side near XXX hotel. What action will be taken against them? So they don't know, let's say, the vehicle number, or let's say which area it was. So they may come back to you saying that you should provide more details. And then there are a set of questions or set of messages which will not get any reply. That this is a particular message in which the person had posted some weapon on the website that maybe this would be useful for police department. So this kind of message may be ignored and may not get any answer. So if you look at it, all these are classes, and this now becomes a multi-class classification kind of a problem. So when we are doing a classification problem, this is, let's say we had some 22,000 posts, And since we are looking at supervised approach, we took a random sample of 1,000 posts and got them annotated by a police department. And remember, we do not get it annotated. One post should be at least annotated by 3 people, and then maximum votes can be taken so that it's not biased towards one annotator. So that's the annotation data that we had. And the task is, one is simple, say whether it is serviceable, non-serviceable. And then the other one is to say if it is serviceable, then which category it belongs to. Let's look at some of the features that are developed to solve such a text classification kind of a problem. So a part of this is linguistic attributes that I told you that one of the techniques we will cover is linguistic part. So let's say emotions. They could be anger, disgust, fear, joy, sadness. So LIW is one of the most popularly used tools which uses linguistic science to give some parameters for each of these states. So that's there. It can also give you information on cognitive ability, like how much is the tentativeness, then interpersonal. How it calculates interpersonal is, are you talking about yourself? Are you talking about the second person? Or are you talking about the third person in this particular post? And based on it, it gives some interpersonal score. Similarly, this ask question or not this is something that one can easily program and find out if there are words like how, why, question marks coming, then possibly there's a question being asked. And another feature that one can come up with is what are all entities, like companies, people, organization mentioned there. And why we are coming up with this kind of features is very simple. So let's say if it is a serviceable post, the categories that we saw, then we have already looked at it that it should have definitely some information, like it should have date, it should have date, it should have location, it should have a proper picture or a complaint, let's say picture of where the crime happened or vehicle number. So something like that. That's basically the entities part. And most of the serviceable posts, one could hypothesize that when people really demand something from police, they may be very high on anxiety or anger. And let's say if they are very happy, then it could be the acknowledgement kind of category, that I would like to thank so and so officer. That is why all these attributes we are taking into our algorithm. So when you are doing machine learning or when you are doing NLP, you will have to come up with these features that you want to put into your algorithm if you are using the traditional methods. One more technique to understand the content could be topic modeling. I used LDA. There is another very popular technique, not very popular, but another very helpful technique that's used is non-negative matrix factorization approach. There are, it would basically give you what are the top 10 topics being talked about in those set of 200, 300 posts that you are looking at. So that again can go as a feature in your text classifier. So let's see, when I want to say that whether a post is serviceable or non-serviceable, what I want to see is to understand what features I am taking. Are they different in these two categories or not? Are they different in these two classes or not? And that's where a little bit of statistical analysis would help. So we take LIWC, the one that I showed you in a few slides back, and we get, okay, what is anger in serviceable post? What is the amount of anger mentioned in non-serviceable post? Similarly, what is disgust? What is fear? I calculate all the values, and then I can use some statistical tests to find out if these two are different or not. That will help me understand whether that feature I should use or will it be of any use if I put it into my classifier or not, that I can do that. And overall, this would always give us some aspect of how these two posts are different. So similarly, the other parameters that we looked at, like first person. So if you are complaining, most likely first person you would be talking about, second person could be there. There's less chance of third person coming. So that kind of analysis one can do. Like, I'm just worried if Hyderabad traffic police makes things worse, like always. So it's more of a complaint. Similarly, if we look at the post that police would answer in comparison that police does not, the posts which are more objective, which have more objectivity in them, will get more reply in comparison to which do not have. So these would give you some sense of what kind of features you should take this text, calculate these features, put them into your standard machine learning algorithms like logistic regression, random forest, and then you will get some accuracy to understand whether it is really working or not. So that's a pipeline of how text classification happens, and you can use various techniques to find out what are the best features that are working for you in this particular problem. So let's move to our second use case. So I covered text classification. I showed you a flavor of what is linguistic analysis that's done in NLP. Now moving to the other use case, which is information extraction. This is again a very important and most heavily used technique of machine learning, which is called as information extraction. So let's say I give you a CV and I ask you, please extract name of this person, his phone number, her address from this particular CVs. Let's say that's the task. Now, how do you go about doing that? So one, you would need some kind of training data. Then it should be a scalable solution if you are talking about industry scenario, because you may be getting thousands of CVs per day, and you may want your time should be less than 1 second to parse a particular CV. And then this data that you are getting as an output from your algorithm, it should be compatible with the DB where you store the information. So let's see what is a basic pipeline of if we are doing some CV parsing. One, we have some CVs. Again, it's a supervised learning problem. So we need some training data where we ask some annotators to mark that this entity is name, this entity is phone number. So that's the ground truth data that we create. Now for a CV parser, you can look at it into two tasks. You can divide the task into two parts. First, it's a CV, it's a huge document. So what you can do is you can divide it into subparts. For example, you find out where is the personal information mentioned. Then one can find out where is the education mentioned. What all lines in a CV refer to education. So one can divide this particular CV into multiple subsections and then run a simple NER. Again, I'll come to what an NER is, but that's a named entity recognition module. So what it does is it would, let's say I take this particular CV. This is the classification task that we have already seen in the last part. I take a line of the CV and say whether it belongs to PI section, whether it belongs to work age section, whether it belongs to skill section. Once I know that all the lines in my CV, which section they belong to, I run a specific NER on it, which will be returning me, PI NER would be returning me things like name, address, email. Education one will understand institute, course specification. Similarly, work ex and skills would help you. So that's the major pipeline of a CV parser. So first, let's look at quickly what sectioning is. Since we have already looked at what a classification task is, it's pretty simple. So what we do, I get a CV, which is basically, let's say, a PDF document. Now, first thing I need to do is to find out to convert it into text, because PDF can't be directly fed into the classification module. So what I do is I find out text using tools like Tika. Second, then what I do is once I have this, I do tokenization. It's basically dividing every sentence or finding out these are the sentences in the CV, because I want to classify each sentence. And here what I'm showing is one of the example of how deep learning can be used. So for every sentence, we can find out what is its embedding. You would have heard a lot about word2 vectors, BERT. So take them as a black box, just put this line into it and it will give you some output, which is an, let's say, embedding of this particular sentence. So now what you have done is you started with text and you have come down to numbers. So computers would only understand these numbers. So they take these numbers and try to classify like, okay, which class it belongs to. So let's say we are using a very simple, fully collected neural network for this particular task. So sectioning output would give you a output that it belongs to. This line belongs to this particular section. Going a little bit, I already explained you what text classification is. Now going a little bit into details of what an NER is. So what it does is, if you look at this example on the left side, it is like Michael Jeffrey Jordan was born in Brooklyn, New York. So named entity recognition, these W1, W2 are the words. And earlier in text classification, we were working at sentence level. Now we are working at word level. That's the difference that one should be aware of. Now we are doing named entity recognition. So it should return person should be Michael Jeffrey Jordan, location should be Brooklyn and New York. So let's see what NER does. So broadly, you can look at NER in three, it is going to do three specific tasks. So first one is, as I told you, computers understand numbers. So we take these words and these words are represented in some form of embeddings. So that's the word representation layer. So once you have a word representation layer, the center part, the sequence representation layer, is going to capture the context. For example, it would know that, okay, name is coming here. If you go right to left or whether you go left to right, what is the context? It will try to learn all that through this sequence representation. And then the final one is the inference layer. So this is the layer which is going to give you this output that we use something called as BIO tags. So basically it would say that this is the begin of Michael. That's the beginning of the word of the name. And Jordan would be, let's say, I till here it will be like these are intermediate. And we'll say was born in would get O tag, that it's other, it's outside this particular domain. So these are the three broad things that a particular NER does. There are different ways. One would use CRFs to do the task. Somebody could use deep learning like BiLSTM or stuff. I will not go into details, but this is basic, very basic architecture, you can say, of how an NER would work. So let's look at a simple pipeline. Moving away from, now we did two things. We took a CV, we found out these are the sections. And after finding these are the sections, I also found out these are the entities. So that's done. What is the pipeline going to really do now? So as I told you, deployment is not that straightforward. So we will always need to do some checks, because none of the machine learning or NLP algorithms that we have developed so far are 100% accurate. So we need to do some quality checks. And since this data is going to go into a particular DB, I also need to do some standardizations. So I'll just quickly walk you through some examples later. Similarly, in education, there's another pipeline where we do the sectioning, then we run the NER, we do the validation, and then we do some more mapping, saying that if it is triple IT, it belongs to this particular class. If it is IIT, it belongs to this particular task. This is called as normalization. So we will look at it again in the coming slides. WorkX, if you see, though you know these are the entities in the WorkX section, one needs to arrange them on the timeline. That this was the first company, this was the second company, this was the third company. So after sectioning and NER, you will have to develop something called as a timeline mapping module. So that's the kind of nuance that we see when so far we looked at two things, classification and information extraction. Can it be amalgamation of these two things, classification plus information extraction? Can there be an amalgamation? Yes. So what here we are doing is, what we want is, given this particular CV, I want to do two things. One, these are the exact skills mentioned in the particular CV. And the second one is that there are some projects that this person has done, and can I infer based on these projects that these are the skills that this person has? So first task is going to be information extraction based, and the second one could be a classification or a predictive model you can have. So that's kind of an hybrid approach that one can take. Now moving to the another technique. I spoke about normalization, that if somebody writes Indian Institute of Technology and somebody writes IIT, both should point to one thing in our database. So that's the task. I showed you that that's a task in the pipeline of CV parser that one may need to use. Now let's look at how we are solving that problem. So let's say there's a company which is NVIDIA, there's NVIDIA Graphics, there's NVIDIA Pune, and all three belong to NVIDIA. Then we should be able to combine and club these together. So why it is so important? Since I'm coming from Naukri, I can tell you some of the Naukri examples, and you can also, you would be, it's very simple, right? If Barack Obama, it's some article it is written Barack Obama, in somewhere it is written Obama, and we want that both of these articles are talking about the same person, that there should be a way to knit them together and to say that these belong to the same entity. So how do you take care of that? This is where NLP power or NLP can help. So let's look at some of the challenges that are there in this particular problem. For example, there could be abbreviations. I told you about IIT and Indian Institute of Technology. It could be semantic variation. For example, steam boiler operator and steam turbine operator. Both mean the same thing essentially. Then there could be locations. Google Singapore, Google India, but both for us it's Google. So if somebody is searching for how many people work for Google in my database, I should be able to return all of them irrespective of somebody writing Google India versus somebody writing Google Singapore. Similarly, there could be misspellings. They're like software engineer and somebody maybe instead of double E typing double M. And then there could be a full stack developer, then an extra word coming, freelancer, whereas just full stack developer. So we should be kind of able to say that essentially these both entities mean the same thing. Now, very simple or a basic approach could be finding out overlap between these two words. Let's say Adobe Private Limited. We know Private Limited are sort of stop words, just remove them, and Adobe, there's a good overlap. So based on overlap approach, we can say these are the same entities. But what would happen if it is like NYU School of Medicine and Boston School of Medicine? Then apart, NYU and Boston is only different, rest School of Medicine is same. Then there's a high overlap. But still we can't say that these are same. Another approach could be since we spoke about BERT, word to vectors, these are intelligent representations of the word. Can I just take these words together and see if they can tell me these two entities are the same? That's also the experiments that we perform. It looks like it's not that simple. And these techniques may also have their own drawbacks. So for example, they may not be able to have cater to abbreviations like in the Institute of Personal Management versus IPM. So these are the basic approach, but they may not work in advanced cases. So moving to something which is more advanced. So how do humans solve this problem? How do they solve it? They look at both the words together. Okay, quality assurance and QA procedure. Okay, this is abbreviation. So they are, as a human being, I'm looking at the characters also, I'm looking at the words also, and I'm looking at both of them together, both of these variations together. So can we have something similar for machines? Yes. So there's, again, this is a technique which is called as Siamese network. I'll not go into the details, but these are like twin networks, totally identical. So they have shared weights and they learn they have the same parameters, so they are learning. And that's how, when both these networks are looking together to these variations, they are able to say that, yes, these are same. So that's the broad Siamese architecture. Okay, now I know I'm able to say these two variations are same. When I go into deployment, what will happen? My database is huge. It may have 1 lakh, 3 lakh, 4 lakh variations. And to create these n cross n combinations, I may take days of time to figure out that these two are the same. So is there a smarter way to do it? Then you would have heard about different clustering approaches. So there are clustering approaches which can find some kind of approximate neighbors and reduce the n cross n matrix for you. So that's the kind of change when you are deploying one might need to do. And then it's again the simple exercise that we take these variants, out of which we take a sample that these all could be same. And then we run our similarity module, something like Siamese. And then let's say once we have these scores between these n prime cross n prime variations, we will do some kind of a clustering over it to say that, okay, these all mean same, these do not mean same. So that's the deployment pipeline. The main challenge here is how do you come from n cross n matrix to something which is more tangible to handle. So we looked at so far text classification, linguistics. We looked at what is normalization, or the task canonicalization that I explained in the last part of the problem. Now let's look at knowledge graphs, something that I told you that I want to leave that thought to you. There's a lot of unstructured content. That's where we started. And till now, we've been handling unstructured content into silos, right? Into small parts. Is there a way to save this structured, unstructured information together, or converting this unstructured information into a structured part? So that's where this entire concept of knowledge graphs come. So there's this, Google was once on a mission to organize all the information that's there and make it accessible, more usable. So that's where this entire idea of knowledge graph came in. Some of the popular knowledge graphs that you would have already seen is, if you go and search for Larry Page on Google, there's a small box coming, info box, those are called that. Though that's also coming from a knowledge graph. There's all the wiki data, if you see, that's knowledge graph. LinkedIn has created something which is called as economic graph, where they are plotting all information of their candidates into a graphical structure. So all these are different use cases of knowledge graphs that are popularly used in the domain. This is uh, something which would, if you are looking at unstructured from jobs, this kind of a graph you will get from jobs. Okay, this person for this particular job, this is the location, this is the designation. So a graph will have two edges, it will have two nodes, and it will have an edge in between. So the nodes are the entities and the edge between them is the relation. So that's there. And how difficult or easy this task is. So in Europe, there was an effort to create these tasks, and they did it for a large, manually they created this graph. But when you are talking about the entire web, this manual creation may not be a very good option. So that's where different techniques from semantic, big data, and machine learning help. So I'll quickly just walk you through one such pipeline. Let's say we have structured and unstructured text. For example, there's a job description, or there's, let's say, candidate profile. It goes into a data pipeline, and then it has an information extraction module. All that we saw till now is being applied here. There's an NER for relation extraction. You may use some kind of technique. I'll show you what those are. Then there's sentiment. All these things are used together to find out these what should be the two nodes and what should be the edge between them. That's it. This is one example. Let's say there's a sentence. We are looking for MBA, Masters in Finance. So we will become one node. For MBA in Finance becomes the other. And then our looking is the relation, let's say, in between them. This is very simple way. There could be things like MBA in finance, MBA should be separate, specialization should be separate, finance. There could be different nuances, but I'm just giving an example for simplicity. So these are some very simple tools that one can use and convert these sentences into these triple formats. OpenAI is widely used and can be considered as state of the art. So where all people are using it, let's say now, since the entire data is in a graph format, one can use it to find missing links in the process. For example, something we saw, like I was saying, given this project, I can say this is an inferred skill. Let's say I know the person knows so many skills, then also can I using this graph say that he or she may also know these other things. That's like the inferring part, skill inferring part. Then already I told you that this particular info box that you see is another example of knowledge graphs. Then you would be looking at discover related entities. These all also come from knowledge graphs that are there. In the interest of time, I would probably leave you here that this knowledge graph is an amalgamation of NLP and a large amount of graphs. Similarly, there are other techniques that one can look at. For example, one can, given this picture, can you explain what is happening in that particular picture? So it is computer vision plus NLP. So from here on, the things become more and more it's like combination of two approaches. This is graphs plus NLP. There could be image plus NLP. So all these things evolve. Now we have like Alexa, and there are other things that are coming up. These are again amalgamation of natural language with something else. So that's where I would go back to the expectations and starting of my slides. I think I have already covered most of these things. We covered like what are the variety of use cases that are there being followed. I've tried to cover in different use cases which kind of NLP technique can help you. Some very simple challenges that one can face during deployment. And again, we did not really go into depth, but I tried to cover surface level things. And if there is more interest, we can have like one more session where we can go into depth of one of these techniques. So I think I'll stop here, Niharika.
Yeah, I think thank you so much, because I think it was very well delivered with a lot of clarity. For some reason, there are not many questions, but yes, I would take one question that someone had put when you were explaining NER. So he's asking, instead of NN, can we use any machine learning algorithm? I think if NN is neural networks, I'm assuming.
Yeah, you can use different. I think it's like the sectioning part. If you are saying it's a classification, you could use any of the supervised classifiers that we looked at. And even in NER, people use, instead of deep learning techniques, people also use CRFs. So that's doable.
Okay, and we still, just to remind people who are there watching, that we have some time, we can take a question at the last moment, so feel free to share. And also there were certain questions that people shared at the time of registration, and some of them were quite relevant, so I thought that maybe we could sort of give them a glance. So one of them is that, what type of NLP projects or skills are valuable for employers? Uh, I think what the person wants to ask is what kind of projects maybe they can work on before, sort of landing in a
So
job.
yeah, so I think we covered a lot of scenarios. One might feel that I try to cover it from different perspective. For example, if it is Naukri or if it is LinkedIn kind of a domain, they may have specific use cases around, let's say, CV parser, JD parser, or they may have cases around saying which different skills that belong to this class. If we are talking about Google would have more search kind of the knowledge graph use case that I explained. So depending upon the industry, the use cases might change, but the basic NLP or the techniques that you are going to use would be some of these. So that's how I would put it.
Sorry, I was on mute. So any kind of questions that interview questions that people can prepare for, or they can take reference from
Yes,
there?
so I have certain references for that. So if you are trying to get into NLP domain, there are two very popular courses. Naukri e-learning, you can refer to our domain and our courses. There are courses which are there from Stanford. These are also these are like, if you are still into college level, school level information, so you can go through these courses. That will give you a basic gist of how NLP work. And if you want to practice, so there are a lot of Kaggle data sets that are available. There's also a popular site which is like Papers with Code. So there you can get data, you can get even code. And first thing you can try is to run that code and see what the output you want. Are you getting that or not? So that will give you both. The first one will give you the theoretical knowledge, when you take Naukri learning courses or any of these standard courses, that will give you more theoretical knowledge. But I would recommend that you should definitely go through some of these codes, try it yourself, and that's when I think you will become comfortable and you will be able to crack interviews for NLP positions.
Okay, so we have another question as we speak. What state-of-the-art algorithms or techniques should one possess to enter the NLP industry?
Yeah. So today, it's a pretty evolving domain, but you would see every year there is a new technique that comes. For example, transformers were there, there's GPTs that are there, but basics are most important. You should do a basic course, starting from what TF-IDF is, what lemmatization is, what stemming is. So TF-IDF, or the embeddings that I touched upon today, is a very basic way you can convert text into numbers, because that's how computers will understand. So that's something basic that you should know. Then you should know some of the techniques that we discussed today. What's text classification, what's information extraction, what are different methods that are used in these. For example, somewhere we saw deep learning based methods, somewhere we saw classical methods. So that's there. You would see that person who's taking your interview, there's seldom that you will have only NLP interview. It could be NLP heavy, that one could say that explain me what word embeddings are, what is the difference between BERT, and what is the how it is different from, let's say, Elmo. But you should still possess decent knowledge of machine learning when you are going for an NLP based interviews. These are like tightly knit together.
Okay, there's another question. Being a fresher, how should I proceed in this domain? I think this was also a question which was asked during a lot during when people had put in their queries during registration. So Shalini asked that being a fresher, how should I proceed? And I recently went through Knowledge Graph. Can you suggest something from where I can practice some real world examples?
Okay. So where you should begin, I would recommend take a course. Course would definitely help you structure through and touch upon all the parts. So when we do when we do self study, what happens is one topic we go too much into depth and we tend to kind of ignore another one, which would become a problem, because in interviews you would be checked both on depth and breadth, decent breadth. Again, it's a huge field, so everybody understands that you may not know everything, but there are, let's say, 10 techniques, 10 methods that everybody is expected to know. That's something like statistics, which is applied, which is foundation, or something like linear algebra or maths, which is expected that you should know this, then only you'll be able to do machine learning. So those basics you should know, and for that it is very important that one takes some structured course which covers all different aspects. There's a lot of online web content. You can go through any of the course which is there. For example, I told you, you can go through our content, Naukri e-learning content, and you can also look at Stanford course. These are like open, available. You can do at least one, because then you will know the breadth of the subject. The second thing, that after once you have a decent breadth, it is about going into depth, and that will come through practice. I will not say that when you are a fresher you should start reading research papers. Before going to research papers, before even you understand them, you need the basic concepts clear. So do that. Do some practice of basic, create one text classifier, take some data, try to create a text classifier, try to create a NER, try to create a sentiment classifier. Easily you can find data online, you can find codes also, and you can just try to run those, and then develop, try to complicate the problem, try to tune these algorithms. As a fresher, I think if you have enough knowledge in terms of breadth, some depth, let's say you take 3 of these concepts and you have enough depth in them, that in and out you can have like 1 hour of discussion also if required on that particular topic. It will give you a decent foundation. And once you are hands on as a fresher, if you are joining, definitely they expect one coding round, even if you are not a fresher, even till at least in machine learning, because a lot of IC, it's a independent contributor role till a senior position also. So expect a programming round. So that's the other thing that you may want to do. After that, I think once you are done with these two, then the part of knowledge graphs, because these are like advanced domain questions. Again, you can find courses around them. If you want, I'll probably share some links, but first do the basics, because once you know the basic, that's where you will be able to move to knowledge graph domain.
So since we are already like exceeding the time, so we won't be able to take any more questions. But thank you so much, Niharika, for putting in efforts, and I thought that it was a very clearly delivered presentation.
Thanks, Niharika.
Yeah, thank you so much, and thank you everyone for joining us, and everyone who came up with their questions. Thank you so much.
Thanks, everyone. Nice to
Bye.
meet you.
Yeah. Nice to have you here.